So today we'll be learning how to name aromatic compounds. So firstly, anything that contains a benzene ring is classed as an aromatic compound. So when you are naming these aromatic compounds, you can either have this delocalized model of benzene ring, or you can have this Kekulé's model of the benzene ring. So when we are naming our aromatic compounds, there are two phrases that make things much more simple to deal with, and these are parent and substituent. So a parent basically means the longest chain, and a parent name always goes at the end. Now we have a substituent, which basically means any branches or atoms coming off a compound. Okay, so just going over what I've done already, the methyl group over here is our substituent, and the longest chain, which is propane in this case, is our parent compound. So it's really important to get a hang of this before we can move on to some aromatic compounds. So if we have a benzene ring over here, let's say we have C2H5 over here. So now our parent compound would be the benzene ring, and our substituent would be the branch coming off the benzene ring, and in this case is this ethyl group over here. So if you go about naming this, well, first we'll add the parent compound, which is benzene, and then we'll add our substituent, which is ethyl. So ethyl benzene. If you have 7 or more carbons in the alkyl chain, so let's say 1, 2, 3, 4, 5, 6, 7, 7 or more carbons in the alkyl chain, the benzene ring is no longer called a parent compound. It is actually a substituent now, and as a substituent, it is called phenyl. So if I just go ahead and name this compound over here, well, we have 1, 2, 3, 4, 5, 6, 7 carbons, therefore this will be heptane, and as I said, the benzene will become the substituent, and as a substituent it's called phenyl. In this case, the phenyl is attached to the first carbon, therefore we'll call this 1-phenyl heptane. Moving on to our second point, which is to do with the functional group. So if we have a carbonyl group, so let's say we have C double bond O CH3. If we have a carbonyl group coming directly off a benzene ring, the carbonyl group will actually be the parent compound. And a carbonyl group is simply anything containing a C double bond O. So this would be our parent compound, and hence our benzene would be the substituent. So if we name this, as you can see, the functional group over here in the parent compound is the ketone, and we have 2 carbons, therefore this would be ethanol. And the benzene is in its as a substituent is called phenyl, therefore this would be called phenyl ethanol. Okay, so there are some exceptions that we need to memorize, and these exceptions actually completely defy all the rules we have learned so far. Therefore we have to memorize them. So the first exception is we have a carboxylic group, so carboxylic group attached to a benzene ring, and this would be called benzoic acid. Benzoic acid. Moving on to our second exception, we would have an aldehyde functional group. So C double bond O, hydrogen. So this would be called benzaldehyde. Moving on to our third exception and our final exception. So we now have an amine group, so NH2, an amine group coming off a benzene ring, and this would be called phenyl amine. So what I suggest you do is you look out for these exceptions, because they always will take the priority, and they will be the parent compound. So okay, so now we are just going to apply the previous knowledge we have gained so far and try naming some aromatic compounds. So this is our first example. Let's see, we have a chlorine here, a chlorine here, and a chlorine here. So how would you go about naming this? So firstly, I'll look out for the parent compound, and in this case it is benzene, so I'll write that down first because it goes at the end. So benzene, and now I'll focus on the substituent. So we have 3 chlorines, so no matter where we number the carbons, I mean it's the same anyways. So 1, 2, 3, 4, 5, 6, and so this would be called 1, 2, 3, 2, 5, trichlorobenzene, and it's tri because we have 3 chlorines. Okay, so moving on to our second example, and this is actually to do with 2 substituents. So if I have NO2 over here and a chloro over here, chlorine. So, I mean, we know to start off with what the parent compound is, and that's the benzene. So I'll just go ahead and write that down, benzene. So now if we pay attention to the 2 substituents, well, we have to name them according to the alphabetical order. So if we have a nitro over here and a chloro over here. So if I just write the first letter for nitro, which is N, and then the first letter for chloro, which is C. Now we know that nitro comes after C, therefore it would be attached to the first carbon. So the one that's last in the alphabet would be attached to carbon number 1, and that's the key point in this example. The one that's attached to carbon number 1 is last in the alphabet. So this would be named 3-chloro. Well, 1 nitrobenzene, or it's not necessary to write the 1 down, so we can just call it 3-chloronitrobenzene. Okay, so moving on to our third example, and in this example we actually have 3 substituents. So again, we know what the parent compound is, and I'm just going to go ahead and write that down, which is benzene. So if we look at all the substituents that are attached, well, we have chloro, iodo, and bromo. So if I just write the alphabet C, B, and I. Now we know I is last in the alphabet, therefore it would be attached to carbon number 1, and C is actually second last in the alphabet, therefore we would go across this way. So we would number the carbons across this way. So it would be 1, 2, 3, 4, 5, and this would be therefore called 5-bromo 3-chloro iodobenzene. Okay, so moving on to our fourth and final example, and over here, firstly, we'll identify the parent compound. Well, hang on a minute. I mean, this is one of our exceptions. There's an aldehyde functional group, and we know when we have an aldehyde attached to a benzene ring, it's one of the exceptions we had to memorize, as I mentioned earlier. So this would be called benzaldehyde, our parent compound, benzaldehyde, as that would take priority and it would be called the parent compound. And now we'll move on to the substituents. So we have nitro and we have iodo. So now we know that nitro, the N, comes last in the alphabet. So therefore, if we would go around this way, we'll number the carbons along this way. So we have 1, 2, 3, 4, and this would be therefore called 4-iodo. 2 nitro benzaldehyde.